This is a combined angular offset coupling, and as its name states, it's theoretically capable of compensating for both parallel offset as well as angular misalignment. I say theoretically because I was not able to get this particular design to function as I intended it to. I was hoping that I would be able to use it as an input-output system. Rotate one shaft and the other one spins. Here is the final print. Everything here is 3D printed with the exception of the hot glue. You'll see as I rotate one shaft, the coupling moves, and it doesn't rotate the other coupling. However, when I grab the coupling, I can rotate both shafts simultaneously, and that is the issue that I'm having, dead points. There are 2 dead points in this design, meaning one shaft will rotate and bind the coupling, and the other shaft will not rotate. So you can see if I spin both shafts simultaneously, the coupling and the rotational energy is transmitted smoothly, but if I try to use one shaft as an input and one shaft as an output, this coupler binds up and it does not transmit any rotational energy. I suppose that if you could put a guide in the coupling and have it aligned somehow on some kind of a plane, maybe if it could be held in that plane, the coupling would not slide too much to one end or the other and it could function. I'm not sure, I didn't test it out myself, but as it is, this just doesn't work as I thought it would. So would I recommend this print? Is this something you can print or not? And I would say no, not like this. This doesn't do anything useful that I can think of, but maybe you have a use for it, I don't know. Test it out and see for yourself. I've been inspired to learn more about mechanical design by retired mechanical engineer and YouTuber Thang010146. His YouTube channel has over 3,000 mechanical animations that he created himself, and he's constantly creating new ones almost daily. I've been a fan for a while now, and I would like to challenge myself to recreate some of his designs and 3D print them to see how well they function out of a printer. He's a genius. You gotta check him out if you're interested.